e-health is generally quite difficult. E-health referring to the use of any information or communication technology in healthcare, like a GP patient record system. This project is working on a tool which will be used in the Code for Health platform, which is trying to make life easier for developers of healthcare apps. Code for Health allows users to create what's called operinodes, which provide them with the domain and tools to aid their development. I'll go through an example of making an operonode to outline exactly what it is later. These operinodes can support clinical data repositories. So this is where actual clinical data like patients' blood pressures, etc., would be stored. This project focuses on building a tool to fill these CDR domains with dummy data. A little more context. Code for Health uses a specification called openEHR, which is focused on using electronic health records as the focal point of all transferring of data. We talk a lot about AirScape, which is just an implementation of these standards, which provide a set of concrete API, which you can use to manipulate health data. There's another specification which is called FHIR. This is treats everything like a resource. So a patient would be an XML file, and then another XML file contains those XML elements, and that's just how it's all built. The aims. So building a full stack web development skill set from the ground up, building this app. RESTful architecture and APIs is probably the most crucial part to pick up on. It's the foundation of most of these technologies, and especially grasping the fact that it's just a layer which allows an entry point to resources, and that's kind of the key aspect to pick up. JavaScript skills, because there's a previous build of this tool which exists in Node.js and AngularJS, which Code for Health platform uses for its front ends. Java skills and knowledge improvements, so being able to build Java server-side, I should say, services. Frameworks like Maven, learning about health informatics, and just being able to work on a tool which fits into a much bigger tool, much bigger scale project, because that's most likely the most relevant thing I could do, especially when working for a big company. Like the previous projects I've done, I've been making like a very self-contained app, which can be built from the ground up, whereas on a industrial scale, it's impossible to work on a full app like that. You'd be working on one specific part, and this project is a good way of introducing that line of work. Ultimately, we want to build a web service which is accessible through a front end, but largely just accessible via RESTful API. The front end uses these RESTful API to populate a CDR domain, fixing the previous build and turning it into Java. So the website is available at this URL, so I can bring it up here. It's hosted on Azure, and this is it. This is the front end, and you can also access the API by just putting /API and sending requests to this address. Before we start as well, I'll clear up quickly what a patient record is. So an EHR is basically a folder. It's like if you go into a GP and you say, I want to see my health record, this is the folder they give you, your EHR, which contains everything else. A big focus in this is committing compositions to this EHR. Composition is just a unit of an encounter, like it could be a GP report, a set of nursing measurements, just anything that they measure and then upload, that's a composition. We have to upload templates, which are basically schema, which outline what the composition may contain. It will have rules like blood pressure can't be above like 1,000 because that's madness, and just what to expect. Like it's largely for it's like the schema if this was a relational database. There's also personal info like names and addresses. This is referred to as demographics. These are expressed in either a FHIR patient XML resource or a Moran JSON resource, which I'll show you later. Okay, there's 3 streams of usage. There's making a single patient at a time, or making multiple patients at a time, either through a CSV file or just a request. To show you again just what a patient file is, so actually I'll show you what an operino is. So when you log into the Code for Health platform and make yourself an account, you can create an operino here and make it active. And this is where my app would fill in. They'd probably just send a request to the back end and it would fill up this operino here. Demo video. And here you get a username and a password to access this domain. And you can add a CDR component. Here we are. And this is where you'll store your data for your health app. This is just to take away, so the developer might be building, I don't know, a big GP system. He can just let this all do the back end. He just sends the fires off API requests, RESTful API requests to populate the server. So I'll show you first how to provision a single patient. That's easiest done through the front end. So you would enter your username, which is outlined from the Operaino here, and your password and a base URL where it's stored. You'll get an email with the base URL. You'll get an email with all of these. It'll be something like this. So here's the username, password, and base URL. For this video, I'm going to be using an old server because there's currently an issue on the front end for the EHR explorers. But yeah, that's generally what you would do. So I will be using this specially assigned domain. So username, password. Now I can skip a demographic, which means that there's no health data associated with this, which was requested by the client, or I can put a demographic like a fire demographic in. I'll just show quickly what it's doing, all the little steps. So first it gets a session, it uses your username and password to log in and get a session ID, and then this session ID is passed into all the other API requests in order to authenticate you, so just not anyone can access your data. So here's the fire demographic, which is created here and located on this server, which the MSc, SSE students who I was working with, they built this, and that's what I communicate with. It creates the EHR, uploads a template to this EHR, which then readies it for this composition. And here you have a configuration. So there's the subject ID, which links this demographic to this EHR. Just to outline again, in case you're unclear, this is the domain. The demographics are separate. The domain has EHRs like this, and in these EHRs are compositions and a subject ID, which leads it back to the demographics which are stored separately on this subject ID. And then when you click this, it would have all the info of that patient. This is just an example. It's not fully represented, but our report details it all more. You can also, essentially the backend is just sending this request and filling in the blanks. So it's sending this password, username, base URL, and where the fire demographic is located. Another option is to import a CSV file, which outlines a bunch of patient measured data. And then it makes multiple EHRs or submits that data to multiple EHRs. So an example here, you need to set a header with this. So you just need the body and a header which contains a valid session ID, which means you've logged in before and you just pass that session ID to it. So I'm going to use Postman to show that. So here's the file, here's the subject ID. So this will pass through each of these rows and create a composition containing these stats and mapping them to a composition, a JSON object, which has these as values and these are keys, these as values. That's the composition object, which is then uploaded to this subject ID. If there is no EHR associated with this subject ID, it will create one. So I just need to log in, so I can use this session ID which I created here. Pass it as an EHR header. Send. And that'll take a few seconds, that'll take a minute or so. The other option is the multi-patient provisioner, which is similar enough to the single patient provisioner, except this is only accessible through the backend, and you have to specify a few more attributes in the request body. So for instance, a patient's file, which is a file internal to the system. This patient's one file contains 20 patients. There's also another one which is single patient and patients all, which contain respectively 1 and 100 patients. And you can also customize what kind of data goes in. So allergies, vitals, problems. A GP may only be interested in allergies and vitals for their system. So they only upload that and don't waste time. And a demographic type. So if this string here is anything apart from random fire, there'll be no demographic created. They will just do the rest of the quest. If it's fire, each EHR will have a fire demographic associated, and each or Morand and a Morand demographic. The import CSV is finished. So here we can see it returns a CSV file with the EHR ID, with the composition ID, which has been uploaded, and any errors, and there are none here. So now this subject ID has this composition associated with it, and the same for all of these. So this is useful if a GP just wants to move his data from a spreadsheet onto this server. Again, this is just a note that I'm using for this demo this old URL, but you should use the newer URLs. The data does get onto it, it's just you can't access the EHR Explorer, which I'll show you in a second when this request is done. So I'm going to fire off an example multi-patient provisioner request to this domain. And what happens is it gives you a ticket. So it fires off, starts the script, and then tells you where the location will be afterwards. So here you can see this is the progress of the script. Here we are. And as an example, I set this one earlier, which did the patient's all file, which contains 100. So we can second, this should be done now. Yep. So you can see all of this data has been committed. Yep, 105. And there we are. Oh, we can fire off a single patient request as well, just as an example, yeah. And it's doing the same thing, just contacting the back end. This will take a couple of minutes to finish, but I will log into the EHR Explorer where this data will ultimately go. Actually, I'll do that in a minute when it's done. EHR Explorer show you, it's like a PHP MyAdmin for exploring the EHRs which you upload. The new server instance is currently broken, which is why I'm using this old one. That's the multi-page provisioner. So I'll quickly run through the technical challenges. A large part of this was just working with so many new frameworks and platforms and just integrating them all into a single project. So like Java, Node.js, AngularJS, MySQL for the database holding the tickets. Also getting to grips with asynchronous programming as a concept, especially with the Node.js build. It made heavy use of callbacks due to the fact that Node.js just tends to fire everything at once unless you frame it in that way. Also, I had to use this approach for the multi-patient provisioner because if you keep a request active for too long, it will cut off after a while. So I just had to return the request immediately and run it in the back end separately and give a ticket location where it will be stored later. Understanding RESTful architecture and API. Working with so many different servers and services, especially when those servers go down and having to find ways around it, like using this old server. Most of the time was spent mapping and transforming data into differing formats and then firing them off using the REST requests to the right place. And working with cloud services was another challenge. Hosting the web app and making a MySQL database using the command line tools and then hosting it up on a cloud. And managing concurrency issues. I tried to address that by having data sources, which I read up on for this project in order to address multiple people using the app at the same time. The problems which the client wanted me to solve were the fact that it was written in JavaScript. The previous stack was limited to a single vendor CDR. It basically depended on too many other services which might not be available in all CDRs, which is what it refers to as vendor neutral. So I replicated the import CSV tool and made it able to skip demographics for the main parts. I made this provisioner compatible with Fire-based demographics by working with the other group. Customization of the dummy datasets by having those booleans for choosing what types of data you want. And also solve the issue where the previous build cut off after 20 or so requests, so you needed to run in batches. This one can just handle any amount, just takes a little bit longer. And that request shall be done now. Yep. And I'll quickly log in and show you what it is. And here you can see all the data that's been uploaded. Oh, actually, there's the EHRs.